Welcome back. The next law that we're going to look at is the combined gas law. I'm not really sure it's been coined by any chemist or physicist. I'm going to guess this is just a way of convenience developed by people working out a problem. So the combined gas law is not really attributed to anybody, but what we're really trying to achieve is you'll be given a set of pressure, volume, and temperature, and you may be given pressure and volume in a newer condition. You may be asked to solve the temperature. So basically, it's two set of conditions for pressure, volume, temperature, pressure, volume, temperature. So here's how the equation looks like. So there's a problem. As I said, except the ideal gas law, where pressure and volume have to be converted to atmosphere and liters, temperature is one thing that must be converted irrespective of where it appears. So in this case, the pressure and volume could be left alone, but temperature must be converted to Kelvin. So if 10 liters of oxygen at STP are heated to 512 degrees, what will be the new volume of the gas if pressure is increased? So it's very important first to understand what it is that you're calling P1, V1, and T1. So if 10 liters of gas at STP, so all of this will be part of your initial condition. So V1 is 10 liters, and STP is 0 degrees, which is 273 Kelvin, and P1 is 1 atmosphere. That's what you're starting with. So these are your initial conditions. It's heated to 512 degrees. So T2 would be 512 plus 273. That's what you need to do to get it into kelvins, right? So it'll be 512 plus 273 is 785 Kelvin, right? And the pressure is given. Now keep in mind, I purposefully created this problem to really make you work hard for getting the right numbers and actually play a little bit with your math skills. Now this is given in millimeters of mercury. Even though you do not have to convert, but this value is in ATM, so we cannot have two different units for the same pressure. So 520 millimeters of mercury, we know that for every for 760 millimeters of mercury, that's the conversion factor. Of course, you do not have to remember that. It will be in the appendix. So you got to convert the millimeters of mercury back to ATM. So that'll be roughly about 2 ATM. Okay, now we can find V2. Right, so P1 is 1 times 10 over 273 equals, you see how systematically I'm approaching the problem. I'm just not going on doing crazy things. Once I set it up, I work it out and then just get it all done. Oh, sorry, V2 times 2 over 785, right? Proceed systematically. There's no rush. You're going to have maybe one problem on the test. So if you do all that, 10 over 273 times 785 divided by 2. So it's about 14 liters. So this is algebra. This has nothing to do with really chemistry, except there is some chemistry there. So here's a practice problem. So here's how the problem concluded. And here's a practice problem I want you to solve. And that'll be part of your My Thoughts. So stay tuned for, I think there's one more left.